Welcome to Breaking News to Trading Moves. We are looking at a hard data point today. A specific agreement between two, massive players in the tech space that gives us a very clear picture of where capital is actually flowing.
It's good to be here. And you're right, this isn't speculation, it's not a rumor. We're looking at a signed paper trail.
We're talking about the agreement between NVIDIA and Meta Platforms. And the headline is that NVIDIA has signed a multi-year deal to supply Meta with millions of AI chips.
Millions. That's the number on the table.
Right. And, usually when we see these headlines, the market sort of glosses over the details. They just see Meta buys chips, the stock moves, and that's it. But looking at the documentation here, the hardware list is specific. It's not just the standard graphics cards we're used to hearing about.
That's where the real story is.
Yeah.
The scope of this deal.
Yeah.
That's what matters for investors. It covers NVIDIA's Blackwell GPUs, which are, the current top-tier offering, and the future Rubin GPUs.
Okay.
But the part that really changes the math for the rest of the sector is the inclusion of the CPUs.
The central processing units.
Correct. The deal includes standalone deployments of NVIDIA's Grace CPUs and their next-gen Vera CPUs.
Okay, that is the detail I want to zero in on, because for the last decade, the data center formula was pretty standard. You buy a GPU from NVIDIA for the heavy lifting, sure, but you buy the CPU, the thing that runs the operating system, from Intel or AMD.
Always.
This deal says Meta is buying both from NVIDIA.
It's a change in architecture.
Yeah.
So what we're going to do is walk through exactly what this hardware does, and then we'll look at who wins and, who loses based on this specific contract.
Let's keep it grounded. We aren't predicting, the future of humanity here. We are looking at mechanics. If Meta spends billions here, who gets paid and who gets left out?
Yeah, exactly.
So let's start with the hardware itself. You mentioned Blackwell and Rubin, the GPUs. But explain the CPU side. Why does Meta need NVIDIA's CPU? Why not just stick with the standard Intel chip?
Think about a server rack like a team. The GPU is the star athlete. It does all the heavy lifting, the training of the AI models.
Right.
But the CPUs is the coach. It's the traffic cop. It directs data to the GPU.
And historically, that traffic cop was an x86 chip from Intel or AMD.
Exactly. But as these GPUs have become faster, exponentially faster, that traditional traffic cop, it just can't keep up. It becomes a bottleneck.
The data can't get to the GPU fast enough.
That's it. NVIDIA's Grace CPU is built differently. It uses a different architecture that's designed specifically to feed data to NVIDIA GPUs at maximum speed.
So by buying the Grace and Vera CPUs, Meta is essentially trying to remove a speed limit on its own infrastructure.
That is the logic. And the fact that they are deploying them as standalone units tells us they're committed to this. This isn't just some small test pilot.
And this is all happening inside Meta's data centers. So for the tickers involved right at the top, we're looking at NVIDIA, ticker NVDA, and Meta Platforms, ticker META.
Those are the primary players, and the market relevance is immediate. First, it's about demand visibility. Investors are constantly asking, is the AI spending slowing down?
Right, the fear that the hyperscalers, Meta, Google, Microsoft, are all going to suddenly close the checkbook.
Exactly. A multi-year agreement for millions of chips. Well, that answers that question. It confirms that the projected budgets are converting into firm orders. You don't sign a deal like that if you plan to cut spending next quarter.
It puts a floor under the revenue projections.
It does. Secondly, it's about that stack expansion we touched on. NVIDIA isn't just selling the accelerator card anymore. They're moving into the CPU slot. That increases their share of wallet for every single server rack.
They're capturing more revenue per square foot of the data center.
And finally, there's the build-out itself. Buying the chips is step one, but you have to put them somewhere. You need to plug them in. That drives the rest of the market.
Which leads us directly to the winners. And we aren't just looking at NVIDIA here. If this volume of hardware is moving, other sectors have to move with it. Let's look at the companies that actually build the boxes.
The server makers. We call this AI compute and accelerators. If Meta buys the chips, they need someone to assemble the racks.
So who are the main beneficiaries there?
Well, aside from NVIDIA, obviously you have the assemblers. The text points to Supermicrocomputer, ticker SMCI, and Dell Technologies, DELL.
Why them specifically? Can't anyone build a server?
Not at this density, not at this speed. These systems are incredibly complex. Supermicro and Dell have spent years aligning their engineering with NVIDIA's reference designs. When NVIDIA releases a new chip like Blackwell, Supermicro, and Dell, they often have the chassis ready to go immediately.
So it's about speed to market. If Meta wants these millions of chips deployed now, they go to the partners who have the designs ready.
Precisely. It's platform lock-in. The volume just flows downstream. NVIDIA ships the silicon, but Dell and Supermicro ship the finished cabinets.
Let's talk about the second category of winners, which I think is often overlooked: power and cooling.
This is physics. You cannot cheat physics.
We know these new chips consume a lot of electricity.
But they do. But it's not just about the electricity going in. It's about the heat coming out. The Blackwell and Rubin GPUs run extremely hot. The Grace CPUs just add to that thermal load. When you pack them densely into a rack to get maximum performance, you generate a massive amount of heat in a very small space.
And your standard office building AC isn't going to handle that.
Not even close. You'd sound like a jet engine and you'd still probably melt the components. You need advanced thermal management. We're talking liquid cooling, rear door heat exchangers, highly specialized power distribution.
Who makes that gear?
The names identified here are Vertiv, ticker VRT, and Eaton, ticker ETN.
Vertiv and Eaton.
Yes. Vertiv, in particular, has specialized in these high-density cooling solutions. The relationship is almost linear. For every dollar spent on these high-end AI chips, a certain number of cents must be spent on power and cooling just to make them work.
It's a required attachment. You can't buy the Ferrari engine without the radiator.
That is a fair analogy, yeah. If Meta is buying millions of hot chips, Vertiv and Eaton are likely selling thousands of cooling units and power systems to support them.
Okay, then we have the third category of winners: networking.
The plumbing.
We talked about the CPU being the traffic cop inside the server, but these servers have to talk to each other, right?
Correct. AI training is a distributed workload. You might have 10,000 GPUs working on a single problem at the same time. They need to constantly share their results with each other to update the model.
And if the network is slow,
the GPUs sit idle. And if you paid, I don't know, $30,000 for a GPU, the last thing you want is for it to be waiting for data. So you need high-speed switching and interconnects.
who dominates that space?
The text highlights Arista Networks, that's ticker ANET, and Broadcom, ticker AVGO.
Arista and Broadcom.
Arista makes the high-speed switches that connect the racks. Broadcom makes a lot of the custom silicon, the switching chips that go inside those devices.
So as the clusters get bigger, which they clearly are with this deal, the demand on the network goes up exponentially.
Yes. A larger cluster requires a more robust, faster network fabric. It's another derivative play on the main headline.
Okay, so those are the sectors popping champagne. But trading moves are, in many ways, zero-sum. If NVIDIA is taking up more space in the rack, someone else is taking up less. Let's talk about the losers or the sectors facing pressure.
The most obvious pressure point is on the competing server CPU vendors.
We're looking at Intel and AMD here.
Specifically in their CPU business. Remember what we said at the start. This deal includes NVIDIA's Grace and Vera CPUs.
Tickers INTC for Intel and AMD for AMD.
Right. Every time Meta puts a Grace CPU into a rack, that is a socket that does not get an Intel Xeon or an AMD EPYC processor.
It's a direct substitution.
It is. And we aren't talking about some niche experiment here. We are talking about millions of units over multiple years. That is market share being directly removed from the incumbents.
And it creates a validation problem too, doesn't it?
It does. If Meta, one of the most sophisticated tech companies in the world, decides that the NVIDIA CCU is good enough, or even better for AI workloads, other companies might follow suit. It challenges the dominance of the x86 architecture in the data center.
So Intel and AMD have to fight harder to justify why their CPUs should be the host for these AI clusters.
Exactly. The attach rate, the percentage of AI servers that use an Intel or AMD host CPU, is under threat.
Now, what about the alternative accelerators? We know AMD has its MI series chips, Intel has Gaudi. They're trying to compete with NVIDIA's GPUs. How does this deal impact them?
It's about crowding out.
Explain that.
Meta has a finite amount of capital, even if it is a very large amount, and they have a finite amount of engineering hours. Integrating a new chip architecture, it takes work.
You have to rewrite code, test reliability, build out the racks.
Right, so if Meta signs a multi-year agreement to deploy millions of NVIDIA chips, their engineering teams are going to be fully occupied just deploying NVIDIA chips.
They just don't have the bandwidth to play around with the alternatives.
It makes it much, much harder for a competitor like AMD to get a foothold at Meta in the near term. I mean, the door isn't closed forever, but it is certainly shut for this specific cycle. The incumbent NVIDIA has secured the territory.
So even if the AMD chip is fantastic, it might not matter if the customer is already contractually obligated to fill their data centers with NVIDIA.
Precisely. It pushes the timeline for any potential competitor breakthrough further into the future.
There's one more category of losers mentioned here. AI silicon alternatives. This refers to the big tech companies making their own chips, right? Like Google or even Meta itself.
Yes. There's been this long-standing narrative that eventually the hyperscalers Google, ticker GOGL, Amazon, Meta, would just design their own chips and stop buying from NVIDIA to save money.
We know Meta has its own chip, the MTIA.
They do. But this deal, it really throws cold water on the idea that they're ready to switch over completely.
Because if their own chip was ready to handle this kind of workload, they wouldn't be buying millions of Blackwells.
Correct. It reinforces the NVIDIA-first reality. It suggests that for the highest-end training workloads, the internal silicon just isn't there yet. It validates NVIDIA's lead. It tells the market that even the companies with the deepest pockets and the best engineers still need NVIDIA to compete.
So the narrative that NVIDIA is about to be replaced by in-house chips, it takes a big hit.
It gets pushed back. It shows that the internal chips are likely complementary, not replacements. At least for now.
Let's shift gears to the final part of our discussion. We know the deal, we know the players. If I'm looking at my terminal, what are the key trading angles I need to watch over the next few quarters to see if this thesis holds up?
The first specific metric to watch is NVIDIA's commentary, specifically on supply and margins.
Why margins?
Because ramping up a new product like Blackwell or Rubin is expensive. Manufacturing these chips is very difficult. Sometimes when a company transitions to a new generation of hardware, their profit margins take a temporary dip because the yields, the number of good chips per wafer, aren't perfect yet.
So we need to see if they can maintain those sky-high margins while delivering these millions of units.
Exactly. And watch the timing. They said multi-year. Investors will want to know if that means mostly this year or spread out evenly over 5 years. The pace of delivery determines the pace of revenue recognition.
The second angle is Meta's CapEx.
Capital expenditures. This is the big number. How much cash are they actually burning on infrastructure?
We've seen the market punish Meta in the past for spending too much without clear returns.
We have. So the question is, how does Meta frame this? Are they framing it as spending to win or spending to survive?
If they explain it as a necessary cost to achieve dominance in AI, the market might be forgiving.
But they need to show that this efficiency we talked about, the gray CPU, the liquid cooling, is actually lowering the total cost of ownership over time. If they're just spending blindly, investors will get nervous.
Finally, there's this concept of full-stack NVIDIA. How should we think about that, regarding valuation?
This is critical. Historically, semiconductor companies are valued a certain way.
Right.
But if NVIDIA is selling the GPU, the CPU, the networking card, and the software that runs it all, they look less like a chip maker and more like a platform company.
Like Apple.
In a sense, yeah. When you buy an iPhone, you're in the ecosystem. You buy the services, the accessories. If NVIDIA turns the data center into a similar walled garden where everything works better if it's all NVIDIA, their valuation multiple might expand. They are capturing the whole value chain, not just a component.
That is a powerful position to be in.
It is, and it makes them much stickier. Once you build a data center designed around NVIDIA's power, cooling, and networking requirements, you can't just easily swap in an AMD chip later. You've built the building around NVIDIA.
That brings us right back to the start. The headline was Meta buys chips. But the reality is Meta commits to the NVIDIA architecture.
That is the takeaway. It's an architectural commitment, one that has consequences for the power grid, the cooling systems, and the competitive landscape for years to come.
We have covered the hardware specifics, the winners in cooling and networking, and the pressure on the traditional CPU giants.
It's a clear example of how a single contract can define the mechanics of the market for a long time.
Before we sign off, I just want to recap the tickers we discussed today so everyone has them clear. We talked about NVIDIA, NVDA, Meta, META, Supermicro, SNCI, Dell, DELL, Vertiv, VRT, Eaton, ETN, Arista Networks, ANET, Broadcom, AVGO, Intel, INTC, AMD, and Alphabet, GOGL.
A crowded field, but the separation between winners and losers is getting sharper.
It certainly is. And as we wrap up, a quick reminder, this is not financial advice or buy or sell recommendations. This is purely the opinion of the author. Do your own research.
Absolutely.
Thanks for joining us on Breaking News to Trading Moves. We'll see you next time.